Hello everyone, welcome to my channel Abhilash2021. Today in this video we are going to discuss very important topics which are going to come for the final exam. The first topic is writing a number as a product of its prime factors. So the question will be asked like, express each of the following numbers as a product of its prime factors. Let's take one number, 140. 140 is a even number, so definitely it will come in two table. 2 times 70. 70 again an even number, so 70 comes again in two table. 2 times 35. 35 is odd number, so it won't come in two tables. The next prime number we need to move to, that is 3. 3 table 35 won't come. The next prime number 5. So 5 table 35 comes. Yes, 5 sevens are 35. Now here 7 itself is a prime number, right? So we need not to do further. We'll stop it here. Now 140 can be written as 2 into 5 into 7. Let's take one more number. I'm taking another number, 156. 156 is an even number, right? So it will come in two table. 2 sevens are 14, 1 will remain, 2 eights are 16. 78 is even number, again 78 comes in two tables. So 2 times 3 is 6, 1 will remain, 2 nines are 18. 39 is a odd number, so it won't come in two table. Now we will move to the next prime number, that is 3. So 3 table 13 times is 39. 13 is a prime number, so we can stop the process here. Now 156 equals 2 into 3 into 13. Next topic then, find LCM and HCF by prime factorization method. So let us take some numbers to do this process. I am taking two numbers, 12 and 15. Let us try to find out the LCM as well as HCF by the prime factorization. So first 12 and then 15. If you are perfect means you can write the direct answer. If you are not perfect means do the simple calculation. 12 prime factorization I am doing. So 2 times 6 is 12. Again 2 times 3 is 6. So 3 is a prime number. I can stop it here. So 12 is nothing but 2 times 3. The same way 15, if you do prime factorization, 3 5s are 15. So 15 equals to 5 into 3 or 3 into 5. Now if you want to write the HCF, from the given two numbers we need to pick the number which is common in both. So in these two, if we observe, number 3 is common. So HCF will be 3. And moving to the LCM, write the common number first, that is 3 into whatever the extra numbers are there, write all those extra numbers. Here 2 is extra, write that 2. Into here 2 is extra, write that 2 also. Into here extra 5 is there, write that 5 also. So which is equals 3 into 2, 6, 6 into 2, 12, 12 into 5, 60. So HCF of 12 and 15 is 3, whereas LCM of 12 and 15 is 60. If you feel like this process is difficult, we will go to another topic. 12 prime factorization and 15 prime factorization we will do. So the 12 prime factorization, if you check, 2 times 6 is 12 and 2 times 3 is 6, right? So here 2 is 2 times. So that's why I am writing it as 2 power 2 into 3 is only 1 time. So I am writing it as 3 power 1. Next, coming to the 15, we know already that is 5 into 3. So that 5 I am writing it as 5 power 1 and 3 I am writing it as 3 power 1. Now from these two, for HCF, we need to take the smallest power, and for LCM we need to take the highest power. Observe this one clearly. 3 power 1 and 3 power 1. So out of these two, smallest is 3 power 1, right? So 3 power 1 is the HCF. Now for the LCM, 3 power 1, 3 power 1, smallest is 3 power 1 only, 3 power 1 into, in the extra numbers also we need to check here. Now here 2 power 2, whereas in 15, 2 power only not there. So it means that 2 power 0 will be there. So 2 power 0 and 2 power 2, the biggest we will take for LCM, so it is 2 power 2 into, here 5 power 1 is there. Whereas in 12, 5 power 1 is not there. So that's why I am writing it as 5 power 0. Then out of 5 power 1 and 5 power 0, 5 power 1 is biggest. So LCM we will take as 5 power 1. So now HCF is 3 power 1, that is the same as 3. Here 3 power 1 is 3 into 2 power 2 is 4 into 5 power 1 is 5. So 3 4s are 12, 12 5s are 60. Whatever the method you are doing, both will come the same answer. So which one you are perfect with, go with that method only. Let's take another number 30 comma 50. First let us do the prime factorization of the number 30. 30 comes in two table. 2 times 15 is 30. 15 is an odd number, so it won't come in two table. I am moving to the next prime number, that is 3. 3 5s are 15. Then 5 itself is a prime number. You can stop there, or else you can write one more line. 5 1s are 5. So now 30 equals 2 into 3 into 5. Next moving to the 50. Let us do 50 prime factorization also. 50, it comes in two table. So 2 times 25 is 50. Then 25 comes in 5 table. 5 5s are 25. Now 50, I am writing it as 2 times 5 times 5. Now moving to the writing HCF as well as LCM. Then how will you check once? First, to write the HCF. Pick the number which is common in both. Here 2 is common for 30 as well as 20, and 5 is also common for both 30 and 50. So HCF will be the common numbers 2 and 5. These two numbers we need to multiply. So 2 5s are 10. HCF of 30 and 50 is 10. Now moving to the next LCM. First write the common numbers, that is 2 and 5 into, here extra 3 is there, so write that extra 3 into, here extra 5 is there, so write that extra 5. Now let us multiply all these things. 2 5s are 10. 10 3s are 30. 30 times 5, 150. So HCF is 10 and LCM is 150. Let's take another number 72 and 108. First let us do the prime factorization of the number 72. 72 is an even number, so it comes in two table. 2 times 36 is 72. 36 is again an even number, so it comes in two table. 2 times 18 is 36. 18 comes in two table. 2 9s are 18. 9 comes in three table, so 3 3s are 9. So we can write 72 equals 2 into 2 into 2 into 3 into 3. Next moving to the next number, that is 108. 108 is an even number, so it comes in two table. So 2 times 54 is 108. 54 is even number, again comes in two table. So 2 times 27 is 54. 27 is an odd number, so it won't come in two table. I am moving to the next prime number, that is 3. 3 times 9, 27. 9 can be written as 3 3s are 9. Now 108 equals 2 into 2 into 3 into 3 into 3. Now let us check how to write HCF as well as LCM. So first to write the HCF, pick the numbers which are common in both. 2 is common. Again one more time also 2 is common. 3 is common. Again one more time also 3 is common. So HCF will be 2 into 2 into 3 into 3. So if we multiply this, 2 2s are 4, 4 3s are 12, 12 3s are 36. HCF of 72 and 108 is 36. Next, LCM. First write the common numbers. Those are 2 into 3 2 into 3 into 3 into, here extra number 2 is there, so write that 2 into, in the down extra number 3 is there, so write that 3, which is equals to 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 2s are 72, 72 3s are 216. So the LCM is 216 and HCF is 36. Is how to do LCM and HCF if more than two numbers are given there. So let us find out the LCM as well as HCF of these three numbers, 12 comma 15 comma 18. First let us do the prime factorization of number 12. 2 6 are 12, 2 3 are 6. So 12 equals 2 into 2 into 3. Next number is 15. We know very easily that 5 times 3. 18 equals, let us do the prime factorization of the number 18, which is 2 times 9, then 3 times 3. So 18 equals 2 into 3 into 3. Now you need to pick the numbers which are common in all the three for HCF. So HCF equals to, here 3 3 and 3. Only 3 is the number which is common in all the 3. So HCF is 3. Now moving to the LCM. First write the common number in all the 3, that is 3, into. Now pick the numbers which are common in both also, no problem. So here 2 is there, here also 2 is there. So write that number 2 into. Are there any extra common in at least 2 also? No, not there. Now write whatever are extra there. That is 2 into here 5 into here 3. So if you multiply 3 2s are 6, 6 2s are 12, 12 5s are 60, 63s are 180. So the HCF is 3 and LCM is 180. Next kind of topic is digits topic. In this digits topic, the first question is, what is the last digit? They'll give some number, for example 5 power 1947. What is the last digit of this 5 power 1947? So let us check. 5 power 1 is 5, 5 power 2 is 25, 5 power 3 is 125, 5 power 4 is 625. If we check like this only. Now from this he is speaking about only the last digit, right? So let us concentrate only on the last digit. What exactly the last digit is now here? Here last digit is 5, last digit 5, last digit 5, last digit 5. So it means 5 power any number ends with the last digit 5 only, for n belongs to natural numbers. Kind of last digit question is some number they'll give like 6 power n. Check whether 6 power n can end with the digit 0 or not. So actually to be end with the digit 0, to be end with the digit 0, it need to have 2 as well as 5 as prime factors. Then only it will end with the digit 0. So let us check the given question then. 6 power n, which is equals 6 can be written as 2 3s are power n as it is. So what we said here, to be end with the digit 0, definitely it need to have 2 as well as 5 as a prime factors. Here 2 is a prime factor but 5 is not a prime factor, right? So that's why 6 power n won't end with the digit 0. The same we will write it as 5 is not a factor. I repeat, as 5 is not a factor, 6 power n cannot end with a digit 0. Okay, the next kind of digit question is, for example, if I have a number 2 power 1947. For example, if we have a number 2 power 2, it means 2 2s are, that is 4. And if I have something 4 power 3, that means 4 into 4 into 4, which is equals to 64. Now here 2 power 1947 means 2 into 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 2, 1947 times, right? So like that, after if you write means you will get some answer. In that answer, how many digits are there? That is the question. So how to solve this one? For the given question, first keep log. So that will be log 2 power 1947. In the logarithms, if the power is there for the main number, it will go to the front as it is. So it will be 1947 times log 2, which is equals to 1947 times log 2 value will be given in the question itself, that is 0.3080. Now multiply these two numbers, 1947 into 0.3080. Let us check what it will be. 599.676. Now what will be there before the decimal? For that, add 1. Here we have 599 before the decimal, right? So 599 add 1, always only we need to add 1. So 509 plus 1 equals to 600. So in the expansion of 2 power 1947, 600 digits will be there. The next question is, explain why 7 into 11 into 13 plus 13 is a composite number. Okay, let us rewrite the given question again. 7 into 11 into 13 plus 13. Now here 7 into 11 into 13 and this 13 both are separated by plus a symbol, right? So that's why 7 into 11 into 13 is one term and this 13 is one term. So first term I'm writing as it is, that is 7 into 11 into 13 plus, in the second term we have 13, right? The 13 I'm writing it as 13 ones. Now if we observe these two terms properly, in those two terms definitely one number will be common, so that number here is 13. So take out 13 common. Now from this first term 13 we took, right? So what else are remaining? 7 and 11 are remaining, plus this plus symbol as it is. 13 into 1, 13 we took already common, so remaining is 1, which is equals 13 times 7 11s are 77 plus 1, which is equals 13 times 77 1 plus 1 is 78. Now here if you write the product also, if you did not write also, you can write it as a composite number, because composite number means it need to have more than two numbers as factors, correct? Now here 13 into 78, if you multiply something, we'll get one answer. For that 13 is a factor, 78 is a factor, that number itself is a factor, as well as 1 is also a factor. So obviously here more than two factors are there, so definitely that number will be a composite number only. Trick is, they'll give some fractions or rational numbers and they'll ask us to find out whether the given fraction has a terminating decimal or else a non-terminating recurring decimal, that too without the actual division. Let us check how to solve this one. In the denominator, if number 2 is there, or if number 5 is there, or both number 2 and 5, I repeat, in the denominator after prime factorization, if number 2 is there or number 5 is there, or both 2 and 5 are there with any power, then it will be having a terminating decimal, otherwise non-terminating recurring decimal. Let us check here once. I am taking 1 by 2. In the denominator, we have only 2 with power 1. So, it has a terminating decimal. Next question. 1 by 4. First, 4 is not a prime number. So, let us simplify. 1 by 4 can be written as 2 square or 2 into 2. Here also in the denominator, only number 2 is there. So, it has terminating decimal. Let us take one more number. 7 by 40. Here 40, if we do prime factorization, 2 times 20, 2 times 10, 2 times 5. So 7 by 40 can be written as 2 into 2 into 2 or else 2 power 3 into 5 power 1. Here in the denominator only 2 as well as only 5 are there, no other numbers in the denominator. So we can conclude that this has terminating decimal. For example, I have 15 by 6. First let us do the prime factorization of the denominator. 2 into 3. Now sir said except 2 and 5, if any other numbers are there, means it is a non-terminating decimal. Here besides 2 we have another extra number, that is 3. Then I will say that it has a non-terminating decimal. No, it's wrong. First what you need to do is, before coming to the confirmation that it has a terminating decimal or non-terminating decimal, first cross check that whether any simplification is possible or not possible. So here 3 times 1 and 3 times 5. So the answer is 5 divided by 2. So here in the denominator we have only 2 or 5. So it has terminating decimal. Let us take one more then. 17 divided by 30. 17 divided by 30. If you do the prime factorization, 5 times 6. 6 is not a prime number. So 2 times 3. So 30 can be written as 5 times 2 times 3. Now if we observe here, we need 5, that's okay. We need 2, that's okay. But besides 2 and 5, some other number is also there which is not required for us. So that's why it has non-terminating repeating or non-terminating recurring decimal. Find the HCF and LCM of 60 and 100 by prime factorization method. Almost in every exam, one question will be there related to HCF or LCM or both together, and that too by prime factorization method only. So first let us do the prime factorization of the number 60. 60 is an even number, so it comes in two table. 2 times 30. 30 is an even number, 30 comes in two table, so 2 times 15. 15 is not an even number, so it won't come in two table. Let us move to the next prime number, that is 3. 3 times 5 is 15. Now here the last number, that is 5 itself, is a prime number, so we not to do any further process. Next number 100 I am taking. 100 is an even number, so it comes in two table. 2 times 50. 50 is an even number, it comes in two table. 2 times 25. 25 is not an even number, so we'll go to the next prime number. 3 table 25 won't come. Next prime number 5. So 5 times 5 is 25. Now here 5 is a prime number. We can stop the process here. Now let us write 60 equals 2 into 2 into 3 into 5. Whereas 100 equals 2 into 2 into 5 into 5. Now from these two, to write the HCF, first we need to circle the common numbers. So HCF equals, now pick the numbers which are common in both. Let us check once. In these two, 2 is common. Here again 2 is common. And 5 is common. So except these, nothing else are common. So HCF will be 2 is one time common, right? Write it into, again 2 is common, write it into, 5 is common. So 2 into 2 into 5, 2 2s are 4, 4 5s are 20. So HCF is 20. Now moving to the LCM. In the LCM, first write the common numbers. Those are 2 into 2 into 5 into. Now write all the extra numbers whatever are available. Here 3 is extra, here 5 is extra. So write those numbers also. 3 times 5, which is equals 2 2s are 4, 4 5s are 20, 23s are 60, 65s are 300. So HCF is 20 and LCM is 300. Is we have two sets. Set A equals 1 comma 3 comma 5 comma 7, and set B equals 2 comma 4 comma 6 comma 8. Now the question is asking is, are these two sets disjoint sets or not? Every exam compulsory one question will be there based on this disjoints concept. The same disjoint concept we can interrelate to intersection also. A intersection B. In case if A intersection B is an empty set, then we will call that as disjoint. I repeat, if A and B intersection is an empty set, then we call it as disjoint. Nothing but no common element should be there. So first let us try to find out the A intersection B. Here set A we have 1 comma 3 comma 5 comma 7 intersect set B, that is 2 comma 4 comma 6 comma 8. Now if we observe these two sets clearly, is there any common element here? 1 is not there here, 3 not there in the second set, 5 is not there in the second set, 7 is not there. The same way the elements which are there in second set also, those are not there in the first set. So no element is common, so that we will write it as empty set, that is opening and closing the bracket or else with 0 slash. So this is representation of empty sets. Now these two sets are empty sets, no element is common, so that's why we can say that these two sets are disjoint sets, no common element. This question is from polynomials. Zeros of a quadratic polynomial will be given, like 2 comma minus 1 by 3. Then he will ask us to write the quadratic polynomial or else quadratic equation. Okay, the zeros or roots are given as 2 and minus 1 by 3. Then we need to find out the required quadratic polynomial or quadratic equation. So when zeros are given, to write the quadratic polynomial or quadratic equation, the formula is k into x square minus alpha plus beta into x plus alpha beta. Here alpha beta are nothing but the given zeros. One is alpha, one is beta. You can take in reverse also, as the first number as beta and second number as alpha also, same answer only you will get. So let us substitute now. At the till the last step we don't have any work with this constant key, so keep it like that only. X square as it is minus alpha I am taking as 2 plus beta is minus 1 by 3. Close it. X as it is plus alpha beta. 2 is alpha into beta is minus 1 by 3. Let us try to simplify this further. K times x square minus open bracket 2. Here two symbols are there, right? So plus into minus minus 1 by 3 as it is times x. Here plus into minus minus 2 ones are 2 divided by 3. Next k as it is times x square minus open bracket. Now first let us simplify the inside one. We have 2 minus 1 by 3, right? This 2 I am writing it as 2 by 1. So let us do cross multiplication. 2 3s are 6 minus 1 1s are 1 divided by 3 1s are 3. 6 minus 1 is 5 divided by 3. So 2 minus 1 by 3 is the same as 5 by 3 times x as it is minus 2 by 3 as it is. Let us close this. Now k as it is into, I am removing the brackets, x square minus of 5 by 3 x is minus 5 by 3 x minus 2 by 3. Now the second term denominator is 3, in third term denominator is 3, whereas in the first term denominator is not there, right? So that's why what I will do, I will multiply the numerator with 3 and write the denominator 3, so that 3 will get cancelled. As usual we'll get x square only. Now outside one k as it is into, all the denominators are same, so we can write the numerators as it is, that is 3x square minus 5x minus 2 whole divided by 3. Now here we got one denominator 3 in the denominator, right? So to remove that 3 we will take the k value as 3. So if k equals 3, so in the place of k substituting 3, that is 3 of 3x square minus 5x minus 2 divided by 3, so that this 3 will get cancelled, then we remains with x square minus 5x minus 2. This is our required polynomial. The next question is find the slope of the given, that is 4 comma minus 8 and 5 comma minus 2. So first write the x1 y1 and x2 y2 in the given points, that is x1 y1 x2 y2. Slope formula is y2 minus y1 divided by x2 minus x1, which is equals to y2 is minus 2 minus y1 is minus 8 divided by x2 is 5 minus x1 is 4, which is equals minus 2 minus into minus plus 8 divided by 5 minus 4 is 1, minus 2 plus 8 is 6 divided by 1. 6 by 1 is 6. So the slope of the given points is 6. Okay, next one more important question is 2x square plus kx plus 3 equals to 0 has two equal roots. Then find the value of k. Here this question is from quadratic equation, so every time one question will come from this also. If a quadratic equation has two equal roots, then find the missing one. So here if a quadratic equation has two equal roots, then the formula is b square minus 4ac equals 0. Here a and b and c are, this a is x square coefficient, so here x square coefficient is 2, so a value is 2. Next, b is x coefficient, here before x we have k, so b value is k. Next, c stands for constant, here constant is 3, so c value is 3. Now let us substitute in this equation. B square, that is k square minus 4 into a is 2 into c is 3, which is equals 0. K square minus 4 2 is 8, 3 is 24, which is equals to 0. Now here minus 24 I am taking to the right side, so k square equals minus 24 become plus 24. K square value is plus 24, then what will be the k value? So k value will be plus or minus under root 24. Okay, the next question, now this time this is from pair of linear equations, two variables. So two equations are given, 2x minus ky plus 3 equals to 0, and one more equation 4x plus 6y minus 5 equals to 0. Here two equations were given and he is saying that these two equations are parallel lines. Then find the k value. One compulsory question will come on this also. Maybe they will give those two are parallel lines or intersecting lines or coincident lines, and they will ask you to find the missing variable. So here parallel lines they said, right? So first let us write the parallel line condition. A1 by A2 equals B1 by B2 not equals C1 by C2. This is the condition for parallel lines, right? Now let us substitute. First A1, that is first equation, x coefficient 2 divided by A2, x coefficient of the second equation 4. It should be equals to B1, y coefficient of the first equation, that is with symbol minus k, divided by B2, y coefficient of the second equation 6. That should not be equals to C1 and C2. Constant of the first equation is 3 divided by constant of the second equation is minus 5. Now if we observe this clearly, here these two are anyway not equal only, so I am not going to worry about this one. Now I will take this first two only, that is 2 by 4 equals 2 by 4 equals minus k by 6. Doing cross multiplication, 2 times 6 12 equals 4 times minus k minus 4k. So we need to find out the k value, right? Take minus 4 to the left side, so it will be 12 divided by minus 4 equals to k, then k equals to minus 3. So the k value is minus 3, then only those two given equations will be parallel to each other. If sine A equals cos B, then prove that A plus B equals 90 degrees. Again, this kind of question also will come compulsory. Now this we can solve it in two ways. Let us check once. First way is sine A equals to cos B. From the trigonometry table, if we observe sine and cos, for which angle those two values are same, those are 45 degrees. So from that we can say that A is 45 degrees as well as B is also 45 degrees, and is asking to find the value of A plus B, right? So A plus B will be 45 plus 45, which is equals to 90 degrees. The second method is left side we have sine A, which is equals right side we have cos B. Now out of these two, any one you can change, only one, sine A or cos B. So now I am planning to change this sine A. Sine A equals cos B. So this sine A, I am writing it as cos of 90 minus A, because cos of 90 minus theta is sin theta. So that's why sine A I am replacing with cos of 90 minus A, and right side cos B as it is. Now if we observe both left side and right side clearly, cos of 90 minus A equals to cos B, right? So here this trigonometric ratio is cos, this also cos only. Then we can compare the angles. So 90 minus A equals B. Taking minus A to the right side, so 90 equals to minus A will become plus A. So A plus B value is 90 degrees. The next concept is based on the elimination method. Solve 2x minus y equals 5. 3x plus 2y equals to 11. In case if you have any doubt based on this elimination method, you can watch a video which link is given in the description. That video is completely based on the elimination method only. So here 2x minus y equals to 5 and 3x plus 2y equals 11. Now if we observe the coefficients of the x, in the first equation it is 2, in the second equation it is 3. So both the coefficients of x are different to each other. So what we will do is, first equation completely we need to multiply with the second equation x coefficient. Here second equation x coefficient is 3, right? So multiplying with 3. Next second equation we need to multiply with completely first equation x coefficient. Here first equation x coefficient is 2. So let us multiply now. 3 times 2x, it is 6x, minus 3 times y, it is 3y, equals 3 times 5, that is 15. Next 2 times 3x, 6x,
plus 2 times 4 2y 4y equals 2 times 11 22. Now if we observe the symbols before the x coefficients after multiplication, here 6x is positive, here also 6x is positive, both the x coefficients are same symbol, then we will do subtraction. So this plus 6x will become minus 6x, plus 2 4y becomes minus 4y, plus 22 becomes minus 22. 6x cancel, minus 3y minus 4y is minus 7y equals 15 minus 22 is minus 7. Both the sides minus minus cancel, and taking 7 to the right side, so y equals 7 by 7, so the y value is 1. Substituting this y in any one of the equation, that may be before multiplication or after multiplication, is up to you. Now 2x minus y equals 5. I'm taking the first equation. 2x is unknown still, so x as it is minus y value, just now we got 1, substituting equals 5. Taking minus 1 to the right side, 2x equals 5 minus 1 will become plus 1. 2x equals 5 plus 1 is 6. Now taking 2 also to the right side, x equals 6 by 2, which is 3. So x value is 3 and y value is 1. A sphere, a cylinder, sphere, cylinder and cone. Sphere, cylinder and cone have same radius and same height. So if I take the sphere radius as r, the same radius will be there for the cylinder also. The same radius will be there for the cone also. And same height. What is the height of a sphere? Now the sphere height is from this top to this bottom, correct? That is nothing but this diameter. So height of the sphere is diameter. Diameter in terms of radius is double the radius. The same height is there for the cylinder also, that is 2 times the radius, and the same height is applicable even for cone also, that is 2 times the radius. Okay, now moving to the question back again. A sphere, cylinder and cone have same radius and same height. Then find the ratio of their volume. So he's asking us to find the ratio of their volumes. First one, sphere volume, that is 4 pi r cube, is to cylinder volume pi r square h, is to cone volume 1 by 3 pi r square h. Now before substituting some values, first let us check any cancellation is possible here. Pi, 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 I can cancel. Next remaining is 4. R cube is remaining, right? That r cube I am writing it as r square into r dot, here r square as it is into height. Height of the cylinder is 2 times radius, right? So 2r is to 1 by 3 as it is into r square as it is into height is double the radius. So now if you observe all three again clearly, any for simplification, here r square r, here r square r, here also r square r. So it means every variable is cancelled, only constant is remaining. Now in the first part 4 is remaining, is 2, in the second part 2 is remaining, is 2, in the last part 1 by 3 into 2 is remaining. Now here first one, second one, both are normal numbers only, there is no problem with that one. But for the first third one, it is fraction, right? First let us simplify that one. 4 is to 2 is to 1 by 3 into 2. Here in the denominator 3 is there, right? So to remove that denominator 3, everything I'll multiply by 3. So we will get 4 into 3 is to 2 into 3 is to 1 by 3 into 2 into 3. So here this 3 will get cancelled now. Now moving further to the calculation part. 4 3s are 12 is to 2 3s are 6 is to 1 2s are 2. Let us do simplification still. 2 6 are 12, 2 3s are 6, 2 1s are 2. So the volumes of sphere, cylinder and cone are in the ratio 6 is to 3 is to 1. We show that under root 1 plus cos theta divided by 1 minus cos theta equals cosec theta plus cot theta. a maximum number of times they ask the same kind of question in the final exams. So let us check how to solve this one. We have under root 1 plus cos theta by 1 minus cos theta. We need to show that it is equals to cosec theta plus cot theta, right? So first take the given left hand side, 1 plus cos theta divided by 1 minus cos theta. In the denominator we have 1 minus cos theta, right? So multiply and divide by 1 plus cos theta. So 1 plus cos theta by 1 plus cos theta. Keep that under root symbol as it is. Now if we observe the numerator clearly, we have 1 plus cos theta into 1 plus cos theta, right? So 1 plus cos theta into 1 plus cos theta is 1 plus cos theta whole square divided by, in the denominator we have 1 minus cos theta into 1 plus cos theta, that is a minus b into a plus b, nothing but a square minus b square. So 1 square minus cos square theta, under root symbol as it is. Now here if we observe clearly, this square root is applicable for both numerator and denominator. So now itself don't cancel this 2 and this square root, that is completely wrong process. So write the numerator as it is first, that is 1 minus cos theta whole square divided by, here we have 1 square, right? 1 square is nothing but 1. So 1 minus cos square theta, 1 minus cos square theta, from the first identity sin square theta plus cos square theta equals to 1. So 1 minus cos square theta is sin square theta, under root as it is. Now, in the numerator and denominator square is common, so I am taking that as 1 plus cos theta divided by sin theta, for everything square now, as usual square root. Now, this square root and square you can cancel. So, the remaining part is 1 plus cos theta divided by sin theta as it is. Now, the right side part we need to show like cosec theta plus cot theta, right? So, this 1 plus cos theta by sin theta, I am separating it as 1 by sin theta plus cos theta by sin theta. Here 1 by sin theta is nothing but cosec theta plus cos theta by sin theta is nothing but cot theta. If x square plus y square equals 25xy, then prove that 2 log of x plus y equals 3 log 3 plus log x plus log y. Now he's asking if x square plus y square is given as 25xy, then prove that 2 log of x plus y equals 3 log 3 plus log x plus log y. Now this kind of question is also came most of the time, so sometimes with the plus, sometimes with the minus, and sometimes with 25xy, sometimes with different numbers. So whatever it may be the number or question, the process will be same. So just try to find out the small logic in this one. Here right side if you observe, 3 log 3 is given. Normally in logarithms, if any front number is there, means that will go as a power. Then what it will become? Log 3 power 3. That is nothing but log 3 cube is 27. So in our answer we need to have a number 27. But what is the number he gave? 25 he gave. So it means still 2 more I need to add, right? So what I will do is, let us erase this first so that it won't be confusing for us. Okay. First take this given one, x square plus y square equals 25xy. Now from the logic we got to know that 27xy we want, but here only 25 is there, so 2 more I want, right? So that's why both the sides I am adding 2xy. So plus 2xy plus 2xy on both the sides. Now left side part if we observe, x square plus y square plus 2xy, that is the formula of x plus y whole square, which is equals 25xy plus 2xy, it is 27xy. Now in the asking prove, log is there, log is there, log, but whatever we got now in that log is not there, right? So that's why I'm applying log on both the sides. So it will be log of x plus y whole square equals log 27xy. Now here for the power, sorry, for the main number power is there, so it will come to the front as it is. Then we will write it as 2 log of x plus y, which is equals log 27xy. That is the meaning of 27 into x into y. In logarithm, multiplication will become addition. So log 27xy can also be written as log 27 plus log x plus log y. Is the prove that also left side part is 2 log of x plus y only. So that's why whatever the answer we got now, in that left side part I am keeping as it is, that is 2 log of x plus y, which is equals log 27. Prime factorization is 3 into 3 into 3, that is nothing but 3 power 3, plus log x plus log y. Now writing the left side part as it is, that is 2 log of x plus y, which is equals, in the main number if power is there in logarithm it will come to the front, so it will be 3 log 3 plus log x plus log y. How many multiples? How many multiples of 4 lie between 10 and 250? This is one of the most repeated questions again. Sometimes you will ask 4 multiples, sometimes 7 multiples, sometimes 8 multiples. How many multiples of 4 lie between 10 and 250? Now the numbers which are given, if we take in order, 10 comma 11 comma 12 comma 13 comma 14 comma and so on, 248 comma 249 comma 250, these are the given numbers. From this specifically he is asking multiples of 4 only. It means the numbers which comes in 4 table. 4 table 10 won't come, so cross it out. 4 table 11 won't come, cross it out. 4 table 12, yes it will come, 12. Now, no need to check 13, 14, 15, all those things. He is asking about multiples of 4, right? Keep on adding 4. 12 plus 4, 16. The next 4 number is 16. 16 plus 4, 20. 20 plus 4, 20, and so on. Then what is the last number? 250. It won't come in 4 table. 249. It won't come in 4 table. 248. Yes, it comes. So the last number in this process is 248. Now, first number is there, last number is there, and common difference we can able to find out. So we need to find out how many multiples of there. So let us write the nth term formula of arithmetic progression. An equals a plus n minus 1 into d. An, the last number 248, equals a, first number 12, plus n value we need to find out, into d, common difference. Here is speaking about 4 multiple sets, so definitely the 4 only d will be. Now taking this 12 to the left side, so it will be 248 plus 12 becomes minus 12, equals n minus 1 into 4. 248 minus 12 is 236, which is equals n minus 1 into 4. Taking 4 to the left side, so n minus 1 equals, multiplication we become division, 236 by 4. N minus 1 equals 2. 4 5 is a 20, 4 and 36. So n minus 1 equals 59. Taking minus 1 also to the right side, n equals 59 minus 1 becomes plus 1. So n value is 60. It means total 60 numbers are there which are multiples of 4 starting from 10 to 250. Next important question is, if cosec theta plus cot theta equals some constant p, then show that or find cos theta value. So otherwise he will give sometimes cos theta value also, and he'll ask us to prove that cos theta equals to k square minus 1 divided by k square plus 1. Almost in every exam the longest long answers will be there, right? In that one question will be this one. If cosec theta plus cot theta equals to some constant p, then show that cos theta equals k square minus 1 divided by k square plus 1. Now the given one is cosec theta plus cot theta equals p, right? Based on cosec theta and cot theta, we have one identity. First write that identity. Cosec square theta minus cot square theta equals 1. Now here, this cosec square theta minus cot square theta is in the form of a square minus b square, right? So a square minus b square equals a plus b into a minus b. Then cosec square theta minus cos square theta, it is in the form of a square minus b square. Then cosec square theta minus cos square theta can be written as cosec theta plus cot theta into cosec theta minus cot theta equals 1 as it is. Now cosec theta plus cot theta value he gave in the question as some constant p, right? So this total cosec theta plus cot theta I am replacing with a p into cosec theta minus cot theta as it is. cosec theta minus cot theta, which is equals 1. Now taking this p to the right side. Here it is multiplication. If I take another side, it become division. That is cosec theta minus cot theta equals 1 by p. The given question is cosec theta plus cot theta equals to p, and what we got now is cosec theta minus cot theta equals 1 by p. Let us try to solve these two equations. So the given one in the question is cosec theta plus cot theta equals some constant p. Second equation just now what we got is cosec theta minus cot theta equals 1 by p. First, do addition of these two equations, so that cosec theta plus cosec theta 2 times cosec theta plus cot theta minus cos theta cancel, which is equals p plus 1 by p. Let us try to simplify this further. 2 cosec theta equals p into p square plus 1 divided by p. Now taking 2 also to the right side, so cosec theta equals p square plus 1 divided by 2p. Now same two equations, let us do subtraction this time. Cosec theta plus cot theta equals p, and the second equation is cosec theta minus cot theta equals 1 by p. I am doing subtraction of these two equations, so that plus cosec theta becomes minus, minus cot theta becomes plus, plus 1 by p becomes minus. So cosec theta cancel. Cot theta plus cot theta is 2 times cot theta, which is equals p minus 1 by p. 2 cot theta as it is, which is equals p into p square minus 1 divided by p as it is. Taking 2 to the right side, so it will be cot theta equals p square minus 1 divided by 2p. Now by using this cosec theta value p square plus 1 by 2p and cot theta value p square minus 1 by 2p, let us try to form a right angle triangle. Okay, I have one right angle triangle. In this angle I'm considering it as theta. Okay, first one we got cosec theta value, right? So cosec means hypotenuse by opposite. So here hypotenuse is p square plus 1 and opposite is 2p. So this is hypotenuse p square plus 1. For this theta, this will be the opposite, right? That is 2p. Next, cot theta value is given as p square minus 1 by 2p. So cot theta means adjacent by opposite, right? So adjacent is p square minus 1. So for this theta, p square minus 1 and opposite 2p already is there, no problem. Now for this triangle, all the three sides we got, right? So he's asking us to show that cos theta value, right? So let us try to find out the cos theta value from this given figure now. Cos theta equals to adjacent divided by hypotenuse. Adjacent is p square minus 1. So adjacent is p square minus 1 divided by hypotenuse is p square plus 1. If 2 power x plus 1 equals 3 power 1 minus x, then what is the x value? Let us apply log on both the sides. So it will be log 2 power x plus 1, which is equals 3 power, log applying right side also. That is log 3 power 1 minus x. In the logarithm, for the main number, if power is there means it will come to the front side, this power will come to the front side. So here x plus 1, two terms are there, right? So that's why bracket must log 2 as it is, which is equals to, here also power 1 minus x has two terms, right? So bracket then log 3. Now let us try to remove this bracket. X into log 2, x log 2 plus 1 into log 2, 1 log 2 or simply log 2 equals the same way here also 1 into log 3 or 1 log 3 minus x into log 3, it is x log 3. I am keeping x log 2 as it is to the left side, so it will be x log 2. In the right side we have minus x log 3, right? That I am taking to the left side now, so it will become plus x log 2 plus x log 2 equals log 3, which is already right side as it is, plus log 2 I am taking to the right side, then it will become minus log 2. Now here first term, second term, x is common, right? So I am taking it out, x common, then I will get log 2 plus log 3, sorry here mistake, log 3 it is, close it, equals log 3 minus log 2. In logarithm, if subtraction is there means that will become division. So log 3 minus log 2 is log 3 by 2. x into log 2 plus log 3. In logarithms, addition will become multiplication. So log 2 3s are 6, which is equals log 3 by 2. Now we need to find out the x value, right? So the entire this I will take to the right side. So x is equals to log 3 by 2 divided by log 6. Let's take one more interesting question. Find two numbers whose sum is 27 and product is 182. Two numbers whose sum is 27 and whose product is 182. So now this kind of questions, whenever we saw in the exam, we will feel that this question, is it from pair of linear equations into variables, or else is it from quadratic equations? So no doubt at all, whatever the question will come, if you solve with the pair of linear equations also, if you solve with quadratic equations also, will get the same answer in both the cases. But in one of the processes, the process will be little lengthy, so I'm going to explain both the methods. Which one you feel easy, be perfect with that one. Now here, sum of two numbers is 27, right? So one number I'm taking as x and another number is y. So x plus y value is 27. The same way, product of those two numbers is 182, right? So first number x, second number y, which is equals 182. Now let us try to simplify these two answers. How we will do is, first, x plus y equals to 27 is there, right? X plus y equals 27. I am doing squaring on both the sides. So x plus y whole square equals 27 whole square. X plus y whole square can be separated as x square plus y square plus 2 into x into y, which is equals 27 square. X square plus y square value as it is x square plus y square plus 2 into xy value is given as 182, right? So this xy we are replacing with 182, which is equals 27 square. Now here x square plus y square as it is plus 2 into 182, that is 364, which is equals 27 square. 27 square is 729. Taking this 364 to another side. So x square plus y square equals 729 minus 364. Then x square plus y square equals 9 minus 4 is 5, 12 minus 6 is 6, 6 minus 3 is 3. So x square plus y square value we got as 365. Now take the a minus b whole square formula that we are replacing with x minus y. So x minus y whole square formula. X minus y whole square is x square plus y square minus 2xy. X minus y value we don't know, so left side part as it is equals x square plus y square. Just now we got it as 365, right? So x square plus y square, I'm substituting 365 minus 2 into xy is given in the question itself, right? That is 182. So substituting 182. Now here x minus y whole square, x minus y whole square equals 365 as it is minus 2 times 182 is 364. Then it will be x minus y whole square equals 365 minus 1 is 1. Sorry, 365 minus 364 is 1. We got x minus y whole square is 1, right? Then what will be x minus y value? So x minus value is plus or minus 1. In the question itself we gave sum of the two numbers is 27. That means x plus y value is 27, and here we got x minus y value plus or minus 1, right? So first I'll take plus 1 and then I'll take minus 1. So x minus y equals to plus 1, and in the second case, first equation as it is x plus y equals to 27 and x minus y equals to minus 1. Let us try to simplify these two. X plus x 2x plus y minus y cancel, which is equals to 27 plus 1 28. Then x value we know it is 14. That is 28 by 2, right? Next, this x value I am substituting in the first equation, that is x plus y equals to 27. X plus y equals 27. X value is 14 plus y is unknown, which is equals to 27. Now this 14 I will take to the right side. So y equals so here y equals 27 plus 14. If I take another cell, become minus 14. So y value is 13. So x value 14 and y value 13. Now let us move to the second case where we took x minus y value as minus 1. So I'm solving these two equations. X plus x2 x plus y minus y cancel equals 27 minus 1 is 26. So x value will be 13. Now substituting this x value in one of the equations, I'm taking the first equation. X plus y equals 27. So x is 13 plus y equals 27. So y equals 13. I'm taking to the right side. 27 minus 13 it is. So y value is 14. In the first case, x is 14 and y is 13. In the second case, x is 13 and y is 14. Okay, now let us try to solve the same question with the help of quadratic equations. So the question is, whose sum, sorry, find two numbers whose sum is 27, right? So we don't know those two numbers. So let us take the first number as some constant x. Then what will be the second number? He gave in the question clearly, sum is 27 and product is 182. So sum is 27, right? First number plus second number both equals to 27. First number we took as x. Then second number is same like that only and 27 is the sum. So taking this x that side, then that second number will be 27 minus x. So the second number is 27 minus x. Now the product is 182, right? So let us multiply these two numbers, that is x into 27 minus x equals 182. X into 27, 27x minus x into x, x square equals 182. Everything I'm bringing to the right side so that minus x square will become plus x square, plus 27x becomes minus 27x. This 182 as it is because it's already right side only equals 0. Now splitting the middle term into two terms, x square minus 27x, I am writing it as minus 14x minus 13x plus 182 as it is equals to 0. From these two terms x I am taking common, then we remains with x minus 14 and then minus 13 common, then remains with x minus 14 equals to 0. Then we will get the next step as x minus 13 into x minus 14 equals to 0. So the x values are plus 13 and plus 14. The next question is, they gave an arithmetic progression 5 comma 11 comma 7 comma 23 comma and so on, and he is asking one term, that is 301. Check whether this 301 is a term of this given arithmetic progression or not. So first let us go with the an, that is nth term formula. An equals a plus n minus 1 into d. An means which number we are checking whether it will be there in that given progression or not, that is 301. So an will become 301, which is equals to a first term 5 plus n we don't know, n minus 1 into d, common difference second term minus first term, that is 11 minus 5 is 6. 301, I am taking plus 5 to the left side, then it will become minus 5, which is equals n minus 1 into 6 as it is. 301 minus 5 is 296, which is equals to n minus 1 into 6. Now taking 6 also to the left side, then it will become division 296 divided by 6, which is equals to n minus 1. Now this n whether it will exist or not, otherwise this 301 whether this is a term of this given progression or not, this will be decided by this value only, 296 by 6. If it is a normal whole number, then 301 is a given term of the given AP. Whether if this 296 by 6 is not a whole number, like it is a fraction or like a decimal or a negative number, means then 301 is not a term in the given arithmetic progression. So let us check whether 6 table 296 will come or not. So 6, I am dividing 296. 6 4s are 24. 29 minus 4 is 5 and dropping 6. 6 9s are 54. 56 minus 54 is 2. So it means 6 table 296 won't come. So 301 is not a term of the given arithmetic progression. If 3 tan A equals to 4, then find the value of sin A and cos A. So he gave, if 3 tan A equals 4, then find the value of sin A and cos A. Here 3 tan A equals 4, right? This 3 I am taking to the right side, then it will become division. So we will get tan A equals 4 by 3. Now take one right angle triangle. This I am taking as A. Remaining 2, if you want you can keep, otherwise if you are perfect with that means you can not keep, no problem. Now tan value is given as 4 by 3, right? So in general tan means opposite divided by adjacent, right? So this numerator will be opposite one and this denominator will be adjacent one. So this we took as A, right? Then for this opposite will be this BC, so that is 4, and this AB will become adjacent, so that is 3. Now two sides are there for the triangle. Let us try to find out the third side first. So hypotenuse square equals to base square plus height square. Hypotenuse is unknown, which is equals to 3 square plus 4 square. 3 square is 9 plus 4 square is 16. 9 plus 16 is 25. So AC square is 25. Then what is AC? That is 5. So the hypotenuse is 5 units. Now all three sides are there, right? So let us write the values of sin A and cos A. Sin A equals, sin means opposite by hypotenuse, so opposite is 4 and hypotenuse is 5. Next cos A, cos means adjacent by hypotenuse, adjacent is 3 and hypotenuse is 5. Find the zeros of the given quadratic equation 2x square minus 5x plus 3 equals to 0. So to find out the zeros of a given polynomial, I mean quadratic polynomial or less quadratic equation, the process is same. Those are two methods. One is splitting the middle term into two terms, or else by using the formula. So let us discuss both the methods. Which one you feel easy, go with that in the exam. So first one is splitting the middle term, right? 2x square, this minus 5x I am writing it as minus 6x. Okay, the given question is 2x square minus 5x plus 3 equals to 0, right? So 2x square as it is minus 5x. I am writing it as minus 2x minus 3x plus 3 equals 0. From the first two terms, taking 2x common, then remains with x minus 1. Next minus 3 common, remains with x minus 1 equals 0 as it is. So the next will be 2x minus 3 into x minus 1 equals to 0. Make 2x minus 3 equals to 0 as well as x minus 1 equals to 0. So 2x minus 3 equals to 0, minus 3 to the right side. So 2x is equals to plus 3, then x is equals to 3 by 2. The same way, make it x minus 1 also equals to 0. X minus 1 equals to 0, minus 1 if we take another cell become plus 1. So the values of x are either plus 1 or 3 by 2. Now let us solve the same problem with the help of formula. 2x square minus 5x minus 5x plus 3. Here x square coefficient is a, x coefficient is b, and constant is c. So the formula is minus b plus or minus under root b square minus 4ac divided by 2a. Let us substitute now. Minus as it is, b value is minus 5 plus or minus under root b square, that is minus 5 whole square minus 4 into a value is 2 into c value is 3 divided by 2 into a value is 2. So now it will be minus of minus 5 plus or minus under root minus 5 square 25 minus 4 to the 8, 8 is a 24 divided by 2 to the 4. Let us try to simplify this further. Okay, this 5 as it is plus or minus under root 25 minus 24 is 1 divided by 4, which is equals to 5 plus or minus root 1 is 1 divided by 4. Now let us try to solve this by taking one's plus and one's minus. So it will be 5 plus 1 by 4 comma 5 minus 1 by 4. 5 plus 1 6 divided by 4 comma 5 minus 1 is 4 divided by comma 6 by 4. If we do simplification, it is 2 times 3, it is 2 times 2. So our answers are 3 by 2 comma 4 cancel, then answer is 1. So the x values are 3 by 2 comma 1. Sin A plus cosec A whole square plus cos A plus sec A whole square equals 7 plus tan square A plus cot square A. So we need to show that sin A plus cosec A whole square plus cos A plus sec A whole square equals 7 plus tan square A plus cot square A. Here first term if you observe, sin A plus cosec A whole square, it is in the form of A plus B whole square, right? So let us expand it. Sin A plus cosec A whole square is sin square A plus cosec square A plus 2 sin A cosec A plus the second term is cos A plus sec A whole square, right? So if we expand that, it will be cos square A plus sec square A plus 2 cos A sec A. Now sin square A plus cos square A, we have an identity, right? So sin square A plus cos square A value is 1 plus this cosec square A I am writing as it is plus here sec square A is there, right? That also I am writing as it is sec square A plus now this term 2 as it is, sin A as it is. Now cosec A I am writing it as 1 by sin A because we know sin and cosec are reciprocals to each other, plus the last term also 2 as it is, cos A as it is, sec A I am writing it as 1 by cos A because cos and sec both are reciprocals to each other. Now here this sin A cancel, this cos A cancel, then we remains with 1 plus cosec square A plus sec square A plus 2 ones are 2 plus 2 ones are 2. So now here 1 plus 2 plus 2 5 plus we got here cosec square A and sec square A, right? But right side he is asking or speaking about tan square and cot square, right? So cosec square A can be written as 1 plus cot square A, that is from the identity cosec square theta minus cot square theta equals to 1, right? So cosec square theta means 1 plus cot square theta plus sec square A can be written as 1 plus tan square A plus, sorry, that's it done. Now 5 plus 1 plus 1 7 plus cot square A plus tan square A. And LCM and HCF of 40 comma 60 by prime factorization. First let us do the prime factorization of the given numbers. 40 it comes in 2 table, 2 times 20, again 20 comes in 2 table, 2 tens are 20, 10 comes in 2 table, 2 fives are 10. Now 5 itself is a prime number, so we can stop the process here. So 40 equals 2 into 2 into 2 into 5. Next number 60. 60 comes in 2 table, 2 times 30, 30 comes in 2 table, 2 times 15, 15 comes in 3 table, 3 times 5, 5 itself is a prime number, so we can solve the process here. 60 equals 2 into 2 into 3 into 5. Now let us try to write the HCF as well as LCM. To write the HCF, first pick all the common numbers from these two. 2 is common, again one more 2 is also common, next 5 is common. So HCF is 2 into 2 into 5, which is equals 20. Next, coming to the LCM part. First write the common numbers 2 into 2 into 5 into whatever the extra numbers are there, write all those also. Here 2 is extra, here 3 is extra, so write those two numbers also. 2 into 3, which is equals 2 2s are 4, 4 5s are 20, 22s are 40, 43s are 120. So the LCM is 120 and HCF is 20. Next question is, find zeros of the polynomial x square plus 5x plus 6 and verify the relationship between zeros and coefficients. So first let us try to find out the zeros of the given polynomial x square plus 5x plus 6. I am going with splitting the middle term into two terms, x square, 5x I am writing it as 2x and 3x plus 6 as it is. From the first two terms taking x common, so remains with x plus 2, then plus 3 common, x plus 2. Always make sure that in the bracket always same will come. So x plus 3 times x plus 2. Then the x values will be minus 3 and minus 2. Now take one as alpha and the another as beta. First let us find out the sum of the zeros, that is alpha plus beta equals alpha is minus 3 plus beta is minus 2, which is equals minus 3 plus into minus minus 2, minus 3 minus 2 minus 5. Next, product of the zeros alpha into beta equals alpha is minus 3 into beta is minus 2, minus into minus plus 3 2s are 6. Alpha plus beta, that is sum of the zeros, is minus 5. Alpha into beta, product of the zeros, is plus 6. Now here we did sum and product of the zeros without formula, right? Now let's do with formula. Alpha plus beta formula is minus b by a, which is equals. Here if we observe the given polynomial clearly, here before x square there is nothing, it means 1 is there. So x square coefficient is 1, and before x we have 5, so x coefficient is 5 and constant is 6. So here minus symbol as it is, b means x coefficient, so x coefficient is 5 divided by a, x square coefficient, so minus 5 by 1 is minus 5. Next, alpha beta, the formula is c by a, which is equals constant is 6 divided by x square coefficient is 1, 6 by 1 is 6. Now we need to cross check here. Alpha plus beta value we got minus 5, here also minus 5, alpha beta value 6 and here also 6. Okay, here the next question is, two equations are given, x minus 2y equals to 8 and 2x plus y equals to 5. We need to solve for x and y with the help of elimination method. So first equation, if we observe x minus 2y equals 8, here x coefficient, before x nothing is there, so it means 1 is there, so x coefficient is 1. Now let us move to the second equation, that is 2x plus y equals 5. Here before x we have number 2, so x coefficient is 2. Both the cases the x coefficients are different, so we need to do a little process, that is first equation we need to multiply with the second equation x coefficient, which is 2. Second equation we will multiply with the first equation x coefficient, that is 1. Now this 2 will multiply with each and every term which is there inside the bracket. So 2 into 1x 2x minus as it is 2 into 2y, it is 4y equals 2 into 8 16. Moving to the second equation, 1 we are multiplying, right? So if we multiply with 1, everything will be as it is. So 2x plus y equals 5. Now if we observe here, first equation this is plus, second equation also plus only, both are same symbol means we will do subtraction. So when we are doing subtraction, all the second equation coefficients will change. So plus 2x becomes minus 2x, plus y becomes minus y, plus 5 becomes minus 5, plus 2x minus 2x cancel, minus 4y minus y minus 5y equals 16 minus 5 11. So taking minus 5 to another side, y equals 11 divided by minus 5. So we got the y value. Now substituting is this y value in any one of the equations. I'll move to the first equation, that is 2x minus 4y equals 16. 2x minus 4 into y value is 11 by minus 5 equals 16. 2x as it is, here minus and here one more minus, so minus into minus plus, 4 11s are 44 divided by 5 equals 16. Taking this 44 by 5 to the right side, so we will get 2x equals 16 plus becomes minus 44 by 5. The 16 I am writing it as 16 by 1, and let us do the cross multiplication of this. Here 2x equals 16 times 5, 80 minus 1 into 44, it is 44 divided by 1 into 5, 5. So we will get 2x equals 80 minus 44 is 36 divided by 5. Here 2 ones are 2 18s are. So the value of x is 18 by 5. Okay, the next question is how many three-digit numbers are there which are divisible by 7? So first of all, if we speak about the three-digit numbers, first three-digit number is 100, then 101, then 102, and so on till the last three-digit number is 999. Now, in this question, he is particularly speaking about which three-digit numbers are divisible by 7 only. So here, if we observe clearly, 100 won't come in 7 table, so that is not the required number for us. Next one, 101 is also not divisible by 7, 102 is not divisible by 7, then next number 103 is also not divisible, then next 104 is also not divisible, then the first number which is divisible by 7 is 105. So in our arithmetic progression, 105 is the first term. Next, here we are speaking about divisible by 7, right? So keep on adding 7. Next time, 105 plus 7, 112, 112 plus 7, 119, 119 plus 7, 126, here and so on. Next, last number if we speak about it, here we have 999, right? So we need to check whether 999 will come in 7 table or not. So 999 won't come in 7 table. Then before 999, we have 998. Even 998 also won't comes in 7 table. Then if we check like that only, the last number which comes in 7 table is 994. 994 comes in 7 table. So the last number is 994. Now we have the arithmetic progression, right? So we need to check how many are there like this. So taking the nth term formula, an equals a plus n minus 1 into d. An means the last number, double 94. So 994 equals a is first term 105 plus n is unknown minus 1 into d is common difference, right? In the question anyway speaking about divisible by 7, so the common difference is also 7. Now taking 105 to the left side, it will be now the 994 minus 105 equals n minus 1 into 7. Okay, next question is 990, sorry, continuation 994 minus 1. Okay, here 994 minus 105 equals to 889, which is equals n minus 1 into 7. Taking 7 to the left side, it will become division. 889 divided by 7 equals n minus 1. 7 ones are 7. 1 remains, so 7 twos are 14, 4 remains, 7 sevens are 49, equals n minus 1. Taking minus 1 also to another side, so n value will be 127, minus 1 will become plus 1, so n is 128. It means total 128 three-digit numbers are there which are divisible by 7. Okay, the next question is prove that 3 plus 2 root 5 is an irrational number. We need to show that 3 plus 2 root 5 is irrational. So some sentences will be there to be right in the first and the last. So on the contrary, let us assume 3 plus 2 root 5 is rational. So first we will assume that the given question is a rational number. So 3 plus 2 root 5 equals. Then if it is a rational number means then we can able to write it in the p by q form, right? So we'll go with 3 plus 2 root 5 equals a by b. That is the same of p by q. Our textbook is following a and b, so that's why we are also replacing p and q with a b's. And whereas a comma b both belongs to integers, b not equals to 0. If you write one more condition, that is a comma b are prime number, co-primes, that is also fine. Now taking 3 to the right side, so it will be 2 root 5 equals a by b plus 3 becomes minus 3. So for the further calculation, I am writing this 3 as 3 by 1. Let us check what to do next. Left side part I am writing as it is, that is 2 root 5, which is equals cross multiplying a into 1 is a minus 3 into b is 3b divided by b into 1 is b. Now taking this 2 also right side, root 5 equals a minus 3b divided by 2b. Now if you observe this clearly, here right side we have a, b, number 3, number 2. So here as a comma b comma 2 comma 3 are integers, RHS will be rational number, because in the place of a and b, or else we have already number 2 and 3, whatever the number we substitute, always our answer is going to be a rational number only. So here if this right side part is a rational number, then definitely left side part also should be a rational only. But we know clearly that root 5 is not rational, that is irrational. Then this contradiction has arisen due to our wrong assumption. Find p if 2 is one of the zeros of x square plus 3x plus c. The given quadratic equation is x square plus 3x plus p. Now in the question it clearly mentioned that this 2 is one of the zeros, right? So in the place of x substituting 2. So 2 square plus 3 into 2 plus p, make it equals to 0. 2 square is 4 plus 3 2s are 6 plus p equals 0. 4 plus 6 is 10. 10 plus p equals to 0, taking 10 to the right side, so p equals to plus 10 becomes minus 10. Next question is, if 3 comma 1 by 2 are zeros of a quadratic polynomial, then find that polynomial. So when zeros are given, or else when sum of the zeros are given, to find the quadratic polynomial, we have one formula, that is k into x square minus alpha plus beta into x plus alpha beta. So here 3 and 1 by 2 are zeros. So one number we will take as alpha and another number we will take as beta. Here k as it is until the last step, we don't have any work with k, so write that as it is. X square as it is minus alpha is 3 plus beta is 1 by 2 into x as it is plus 3 into 1 by 2. This k into x square minus here 2 3s are 6 plus 1 7 by 2 into x plus 3 1s are 3 divided by 2, which is equals k into x square minus, opening the bracket, 7x by 2 plus 3 by 2. Here this x square denominator is not there, 7x denominator is 2 and 3 denominator is 2, so that's why I'll multiply this x square by 2 and dividing by 2. So now every denominator is same, so we can write it as k of 2 into x square, 2x square minus 7x plus 3 whole divided by 2. Now the work of k comes. Here in the denominator we have a number 2, right? So to remove that denominator, we will use this k value. In the denominator, whatever the value will be there, the same value will assign for k. So here in the denominator 2 is there, right? So I am taking k value also 2 only. So if k equals 2, so then it will become 2 of 2x square minus 7x plus 3 divided by 2. These two cancel, then we remains with 2x square minus 7x plus 3. She is the alone girl.
Okay, the question is, a fraction becomes 9 by 11 if 2 is added to both numerator and denominator. If 3 is added to both numerator and denominator, it becomes 5 by 6. Then find that fraction. So fraction means numerator and denominator will be there, right? So let the numerator be x and let the denominator be y. So here we are speaking about fraction, right? So fraction nothing but numerator divided by denominator. So the fraction will be now Numerator is x divided by denominator is y. So the fraction is x by y. Now what is speaking then? A fraction becomes 9 by 11 if 2 is added to both numerator and denominator. Here the numerator is x, right? So for that x I am adding 2 divided by denominator is y, so for that also I am adding 2. Then if we add 2 for both numerator and denominator, then the fraction will become 9 by 11. Let's do cross multiplication. 11 into x plus 2, 11 into x plus 2 equals 9 into y plus 2. 11 into x 11x plus 11 2s are 22 equals 9 into y 9y plus 9 2s are 18. Bring everything to the left side. 11x. Now I am bringing this 9y to the left side, so it will become minus 9y. 18 as it is, I am taking 22 to the right side, so it will become minus 22. 11x minus 9y as it is, which is equals to 18 minus 22 minus 4. This is equation number 1. Now let us move to the next one then. If 3 is added to both numerator and denominator, it becomes 5 by 6. Then find that fraction. Let us check how to solve this one also. Numerator is x. We are adding 3 divided by denominator is y. For that also adding 3. Then the fraction will be equals to 5 by 6. Now let us do cross multiplication here also again. 6 times x plus 3. 6 times x plus 3 equals 5 times y plus 3. 6 into x 6x plus 6 3s are 18 equals 5 into y 5y plus 5 3s are 15. Now taking 5y to the left side and 18 to the right side. So our equation will be 6x plus 5y will become minus 5y equals 15 plus 18 becomes minus 18. So 6x minus 5y as it is, which is equals to 15 minus 18, it is minus 3. This is equation number 2. Now here based on the first statement we got first equation. Here based on the second statement we got second equation. Let us try to solve these by elimination method or substitution method. So I am going with the elimination method. 11x minus 9y equals minus 4. 6x minus 5y equals minus 3. Now if we observe these two equations clearly, both the x coefficients, one is 11 and one is 6, are different to each other, as well as the y coefficients are also different. One is minus 9 and one is minus 5. So now we cannot solve this directly. So first equation I am multiplying with the second equation x coefficient, and second equation I am multiplying with the first equation x coefficient. So now 6 into 11x 66x minus 6 into 9y 6 9s are 54y equals minus 4 into 6 minus 24. The same as second equation. 11 into 66 sorry 6x 66x minus 11 into 5y 55y equals 11 into minus 3, that is minus 33. Now here this is plus 66, this is plus 66, both are same symbols. So both are same symbols means we will do subtraction. So if you are doing subtraction means the second equation all the symbols will change. So plus will become minus, minus becomes plus, minus becomes plus. Plus 66 minus 66 cancel. Now minus 54y plus 55y, right? So that is 1y or simply y, which is equals 33 minus 24, which is 9. So y value is 9. So y equals 9. Now substituting this y value in any one of the equations, that before multiplication you can substitute or after multiplication you can substitute. Now I am taking before multiplication the equation number 1, that is 11x minus 9y equals minus 4. 11x minus 9 into y value is 9, which is equals to minus 4. 11x as it is minus 9 9s are 81, which is equals to minus 4. 11x taking minus 81 to the right side, which is equals to minus 4. Minus 81 will become plus 81. 11x is equals to minus 4 plus 81 is 77. 11 ones are 11 sevens are. So the x value is 7. Now we got the x value as well as y value, right? So let us write the fraction. Then fraction is x by y, right? So 7 by 9 is our required fraction. 5 years ago, Noori was thrice as old as Sonu. So here two persons are there, Sonu and Noori, right? So let the present age of Sonu will be x. Let the present age of Noori be y. Now, 5 years ago. So, let us try to find out their ages 5 years back. Sonu and Noori. The present age of Sonu is x, right? Then 5 years back it will be x minus 5. Noori's present age is y. Then 5 years back it will be y minus 5. Now let us move to sentence again. 5 years back. Now as soon as you write this 5 years ago ages, forget about this present ages now. 5 years ago, Noori was thrice as old as Sonu. Now here, Noori was right, so Noori is y minus 5. So, y minus 5 is, was, will be, would be, should be, anything is there means equal symbol. Thrice as old as Sonu. Thrice, 3 times Sonu. Sonu's present age was x minus 5. Now if we solve this one, we'll get the first equation. So y minus 5 equals 3 into x. 3x minus 3 5s are 15. Now I am taking y to this side and minus 15 to the left side. So 3x as it is plus y becomes minus y, which is equals minus 5 as it is minus 15 becomes plus 15. 3x minus y equals 15 minus 5, 10. This is equation number 1. Now second equation then. 10 years later, after 10 years, many times the later word will be replaced with hence also. So hence nothing but after again. So 10 years later, that is after 10 years. Let us check after 10 years what will happen then. After 10 years. The same present, ages of Sonu and Noori. Now Soni's present age we took as x, right? Now after 10 years, she will be x plus 10. The same way, Noori's present age is y, then after 10 years she will be y plus 10. Now as soon as we wrote this after 10 years, we need to forget about this present ages x and y. Okay, now what he's saying then. 10 years later, Noori will be, so Noori is y plus 10. Y plus 10 will be nothing but equal twice 2 into as old as Sonu will be. So Sonu is x plus 10. Now let us simplify this. Y plus 10 equals 2 into x 2x plus 2 into 10 20. Y plus 10 equals 2x plus 20. Now taking all the variables one side and alphabets one side. Here I'm taking y to another side. So 2x as it is plus y becomes minus y equals 10 as it is. I'm taking 20 another side. So plus 20 becomes minus 20. So now it will be 2x minus y equals to 10 minus 20 is minus 10. This is equation number 2. Now here we have equation number 1 and equation number 2, right? So let us try to simplify these through with the help of elimination method. Minus y equals 10. So the first equation is 3x minus y equals 10 and the second equation is 2x minus y equals minus 10. Here now if you observe the coefficients, x coefficient is 3, x coefficient is 2, both are different, but here y coefficient is minus 1, here y coefficient is minus 1, so both are same, so directly I am going with this. Now here this minus 1 both the same symbol, so I will do subtraction. This plus becomes minus, this minus become plus, minus become plus. 3x minus 2x is 1x or simply x. This minus y plus y cancel equals 10 plus 10 20, so x value is 20. Now I'll substitute this x value in any one of the equations. So I'm going with this first equation, that is 3x minus y equals 10. 3 as it is, in the place of x substituting 20 minus y equals 10. 3 times 20 is 60 minus y equals to 10, taking 60 another side, minus y equals 10 plus 60 will become minus 60. So minus y equals to 10 minus 60 is minus 50. Minus minus cancel, so y value is 50. So it means Sonu's age is 20 years and Noori's age is 50 years. Moving to the next question. A bag contains 6 black balls. Number of black balls are 6. Next, and some white balls. How many white balls are there? He did not mention that. So that's why I'm taking number of white balls as some x. If the probability of drawing a white ball, probability of drawing a white ball. So how we will write the probability normally? Number of favorable outcomes divided by number of total outcomes, right? Now here, first let us find out the total number of balls. Black balls are 6 in number and white balls are x in number. So the total number of balls will be 6 plus x or x plus 6. Now he is speaking about if the probability of drawing a white ball. Let us find out the probability of white ball first. So number of white balls are x in number divided by total balls are 6 plus x. Okay, now if the probability of drawing a white ball is double, that is 2 times that of a black ball, probability of picking a black ball, 6 black balls are there, so favorable outcome is 6 divided by total outcomes, total number of balls are 6 plus x. Now if I simplify this, x by 6 plus x equals 2 times 6 12 divided by 6 plus x as it is. Now if we observe the left side part and right side part, both the denominators are same, right? That is 6 plus x and 6 plus x. We can cancel that. So remains with x equals to 12. It means number of white balls are 12. The question from polynomials. If alpha comma beta are zeros of 5x square plus 5x plus 1, then find the value of alpha square plus beta square and alpha power minus 1 plus beta power minus 1. Let us observe the given polynomial clearly. The polynomial is 5x square plus 5x plus 1. Here x square coefficient is a. So a value is 5. X coefficient is b, that is b value is 5, and the constant is c. Now he is asking to find out the value of alpha square plus beta square, right? So alpha square plus beta square equals to, with this formula you need to remember compulsory, alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta. Here bracket as it is, alpha plus beta formula is minus b by a whole square as it is minus 2 into alpha beta, that is product of the zeros, is c by a equals to, now substituting the values, minus symbol as it is, b value is 5 divided by a value also 5 whole square minus 2 times c value is 1 divided by a value is 5. Now let us try to simplify more this one. Here if you observe the inside the bracket, both numerator and denominator are same, right? So we can cancel 5 then we will remains with minus 1 square as it is minus 2 times 1 by 5 equals to, minus 1 square is 1 minus 2 ones are 2 divided by 5. This one also I am writing it as 1 by 1. So let us do cross multiplication now. 1 times 5 is 5 minus 2 times 1 is 2 divided by 1 times 5 is 5, which is equals 3 by 5. So alpha square plus beta square value is 3 by 5. Now let us find out the value of alpha power minus 1 plus beta power minus 1. Alpha power minus 1 plus beta power minus 1. When power minus 1 is there means we will write it as reciprocal. So alpha power minus 1 is nothing but 1 by alpha plus beta power minus 1 is nothing but 1 by beta. Doing cross multiplication, 1 into beta is beta plus alpha into 1 is alpha divided by alpha into beta. Alpha plus beta, beta plus alpha both are same, so beta plus alpha I am writing it as alpha plus beta divided by alpha beta as it is. Alpha plus beta value is minus b by a divided by alpha beta value is c by a cancel, which is equals to minus b divided by c, which is minus symbol as it is, and the b value is 5 divided by c value is 1. Minus 5 by 1 is the same as minus 5. So the value of alpha power minus 1 plus beta power minus 1 is minus 5. Sixth term of an AP is 12. Eighth term of the same AP is 22. Then find its second term. So the first sentence is sixth term of an AP is 12. So we know the nth term formula. that is an equals a plus n minus 1 into d. Now if we observe this formula clearly, nth term is there means we are going with n minus 1. So 1 we will subtract, right? Now here sixth term he is speaking about. So sixth term means the formula will be a plus 1 we need to subtract. So 6 minus 1 it is 5. A plus 5d, and the sixth term is given as 12. This is equation number 1. The same way second equation if you observe, eighth term is 22. So eighth term means a plus, from 8 we need to subtract 1. So 8 minus 1 that is 7. A plus 7d equals 22, and this is equation number 2. Let us try to solve these two equations. Here a coefficient is 1, here a coefficient is 1, and these two are positive. So both are same symbol, so I will go with the subtraction. Plus becomes minus, plus become minus, plus become minus. Plus a minus a cancel. 5d minus 7d minus 2d, which is equals 12 minus 22. It is minus 10. Both the sides minus minus symbol cancel. So d equals to, taking 2 to the right side, 10 by 2, which is equals 5. So d value we got, right? Now substituting the d value in any one of the equations. So I'm going with the first equation. A plus 5d equals 12. A we don't know, plus 5 into d value we got as 5 equals 12. That is a plus 5 5s are 25, which is equals to 12. 25 if we take another side, then a equals to 12 plus 25 will become minus 25. A equals 12 minus 25 is minus 13. So the a value is minus 13 and the d value is 5. Now he is asking to find its second term. So instead of second term, if we ask any other term also, bigger term like 10th term, 20th term, 50th term, like that means, then it will be helpful. That's why I'm going with that method only. So second term formula, a plus 2 minus 1, that is 1. A plus 1d. A value we got as minus 13 plus 1d is the same as d. So 5. Minus 13 plus 5 is minus 8. So the second term is minus 8. How many terms of an AP 9, 17, 25, and so on must be taken to give a sum of 636? He is speaking sum of the terms. So we need to go with the SN formula. SN equals n by 2 into 2a plus n minus 1 into d. Now here he is asking how many terms are required. So he is asking us to find the n value. Now here how many terms must be taken to give a sum of 636, right? So Sn value is given as 636, which is equals to n value is unknown. So as it is divided by 2 into a is nothing but first term, right? Here first term is 9. So substituting 9 plus n value unknown minus 1 into d value, that is common difference. Second term minus first term, 17 minus 9, 8. 636 equals, first let us solve inside the bracket completely. N by 2 into 2 nines are 18. Here multiplying with 8, 8 into n, 8n, minus symbol as it is, 8 into 1, 8. Close it. 636 equals n by 2 into, this is 18 minus 8, 10 plus 8n. Taking this 2 to the left side, here it is division. If I take another side, it will become multiplication. So 636 into 2. 636 into 2 equals, remaining all as it is, n times 10 plus 8n. 2 6 are 12, 2 1 carry, 2 3 are 6, 7, 2 6 are 12, 1272 equals n into 10, 10n plus 8n into n, 8n square. Here I am taking this 1272 to the right side, so it will become 8n square as it is plus 10n as it is, plus 1272 will become minus 1272, which is equals 0. Now this is a quadratic equation, right? So by splitting the middle term or else by applying the formula we can find out this one. But here 1272 is a very big number, so first I will try to check any cancellation or simplification is possible for this equation or not. Now here if you observe, the first term 8 and the second term 10 and the last term minus 1272. All these will come in two table, right? So entire equation I am dividing by 2. Always remember, if you are doing something to the left side of the equation, the same you need to do to the right side also. So 8 I am dividing by 2, 10 I am dividing by 2, 1272 I am dividing by 2, then 0 also we are dividing by 2. Of course 0 if divided by anything means nothing will happen, 0 will again. So 8 by 2 is 4 n square as it is, plus 10 by 2 is 5 n as it is, minus 1272 by 2 is 636, which is equals to 0 by anything is 0. Okay, now let us go with this splitting, and here 636 is a constant which is bigger number. So if I multiply that still with a x square coefficient, that is 4 here, so that will be much bigger. So it is very difficult for me, so that's why I'm going with the formula. The formula is minus b plus or minus under root b square minus 4ac whole divided by 2a minus, here now let us check what are ABCs. N square coefficient is a, n coefficient is b, and the constant is c. Now minus b value is 5 plus or minus under root b square, that is 5 square, minus 4 into a value 4 into c value minus 636. Close it. Whole divided by 2 into a value is 4, which is equals to minus 5 as it is, plus or minus under root 5 square 25. Here we have one minus symbol, and here also we have minus symbol. So minus into minus it will be plus. Now multiplying 4 times 4, 16, 16 times 636. That is 10,176. Whole divided by 2 times 4 is 8. Let us simplify this further. Outside I will write as it is until I will simplify the inside of the square root. So it will be now minus 5 as it is, plus or minus under root 10,176 plus 25. That is 10,201 divided by 8, which is equals minus 5 plus or minus. Now here we have inside the root 10,201, right? Which number square is 10,201? So first keep the 201 aside, then the number will be 10,000, right? 10,000 is which number square root? That is 100. Now here the last digit is 1, right? So it means the answer may be 101, because 1 ones are 1, the last digit is 1, or else 109. The last digit is 9, 9 nines are 81, again it will be 1. So it may be 101 or else 109. So we know that it is 101. So under root 10201 is 101 divided by 8 as it is. Now once you take plus symbol, once take minus symbol, so our answer will be minus 5 plus 101 by 8, or else minus 5 minus 101 by 8. Now let us simplify this more. Minus 5 plus 101, right? 101 minus 5 is 96 divided by 8 equals 12. Here minus 5 minus 101 both are negative, so we'll do addition, that is minus 106 divided by 8. Now if you observe this one, in the question he is asking how many terms are required. Terms cannot be negatives ever, terms cannot be in fraction ever, terms cannot be a decimal ever. So this is negative, so this is not required for us. So number of terms are 12. It means 12 terms are required so that the given sum will be satisfied. Question: if the distance of point P x comma y from point A 5 comma 1 and point B minus 1 comma 5 are equal, then prove that 3x equals to 2y. So here we have 2 points. One point is 5 comma 1, that is point A, and another point B is minus 1 comma 5, and one more point, somewhere it is there, that is x comma y, and he is saying that this point distance from these 2 points are equal to each other. It means this point, if I taking as a P, this PA distance and this PB distance both are equal to each other. So PA equals PB. Sometimes in the exams, if instead of giving distance equal, they will give a single word equidistant. So be careful with that word. Now PA equals to PB. So let us find out first PA distance. Point P has x comma y and point A is 5 comma 1. So here this I am taking as x1 y1 and this I am taking as x2 y2. Now let us substitute in the distance formula under root x2 minus x1 whole square plus y2 minus y1 whole square. Here equals under root x2 is 5 minus x1 is x whole square plus y2 is 1 minus y1 is y whole square. Now this is PA distance, right? Let us find out the same way PB distance also then. So here point P is x comma y and point B is minus 1 comma 5. So let us find out the PB distance first. So under root this I am taking as x1 y1 and this as x2 y2. So under root x2 minus x1 whole square, right? So that is minus 1 minus x whole square plus 5 minus y whole square. Now I got the PB distance also. This is PA distance and this is PB distance, right? So now we know that those two are equal distances. So PA equals to PB. Now let us write these two are equal to each other. So then it will be under root 5 minus x whole square under root 5 minus x whole square plus 1 minus y whole square equals under root minus 1 minus x whole square plus 5 minus y whole square. Now here both the sides we have square root, right? So first to remove that square root we will do squaring on both the sides. So if you do squaring on both sides means for entire square will come, for entire again square will come. So the square root will get cancelled. Remove the square root we will remove with 5 minus x whole square plus 1 minus y whole square which is equals to here minus 1 minus x whole square is there, right? Both are negatives means we can convert that as plus. So 1 plus x whole square plus 5 minus y whole square. Now let us expand this. 5 minus x whole square is nothing but 5 square plus x square minus 2 into 5 into x, that is 10x, plus 1 minus y whole square is 1 square plus y square minus 2 into 1 into y, that is 2y, equals 1 plus x whole square 1 square plus x square plus 2 into 1 into x 2x plus 5 minus y whole square 5 square plus y square minus 2 into 5 into y, that is 10y. Now left side and right side, first let us check for the cancellations. Here plus x square, right side plus x square, both cancel. Right side y square, this side also y square, both cancel. Now here we remains with 5 square is 25 minus 10x as it is plus 1 square is 1 minus 2y as it is. Right side we have 1 square, right? That I am taking to the left side, that will become minus 1 square, nothing but 1 plus 2x will become minus 2x. This is 5 square 25, right? So this will become minus 25. Minus 10y will become plus 10y equals 0. Here also we have some more cancellation. Plus 25 minus 25 cancel and minus 5 minus 1 plus 1 cancel. Now remaining are minus 10x minus 2x, that is minus 12x minus 2y plus 10y, it is 8y equals to 0. 12 and 8 both comes in 4 table, right? So that's why I'm dividing by 4. Now it will become 4 table 12 is 3 so minus symbol as it is minus 3x. 4 table 8 is 2, so 2y equals to 0. Now taking 2y another side, minus 3x is equals to plus 2y will become minus 2y. Both sides minus minus will get cancelled, then remains with 3x equals 2y. If minus 2 comma 1 b a comma 0 and c 4 comma b and d 1 comma 2 are the vertices of a parallelogram, then find a comma b. Here this is a parallelogram. Write the 4 vertices a b c d. Point a is given as minus 2 comma 1 and point b is given as a comma 0. Point c is given as 4 comma b and point D is given as 1 comma 2. Now, whenever he is speaking about the vertices of a parallelogram and some missing are there in the vertices, then we need to go with the midpoint of the diagonals. So, AC diagonal midpoint is exactly equal to the BD diagonals midpoint. That is a property of a parallelogram, that is midpoints of the diagonals are equal to each other. So, that is nothing but midpoint of AC equals midpoint of BD. What is the formula to find out the midpoint or mid value? X1 plus X2 by 2 comma Y1 plus Y2 by 2. Now first let us write for this AC. So this I am taking as x1 y1 and this I am taking as x2 y2. So here x1 plus y1 x1 plus x2, right? That is minus 2 plus 4 by 2 comma y1 plus y2, that is 1 plus alphabet b by 2. This should be exactly equals to the midpoint of another diagonal, that is BD. So this I am taking as x1 y1 and this as x2 y2. So x1 plus y1, sorry, x2, that is a plus 1 by 2 comma y1 plus y2, 0 plus 2 by 2. Close it. Now make the x coefficient equals to x coefficient and y coefficient equals to y coefficient. That is minus 2 plus 4 by 2 equals a plus 1 by 2, which is 1 plus b by 2 equals 0 plus 2 by 2. If you observe the denominators, both the side by 2 is there, you can cancel. Then only we can work on numerator. Minus 2 plus 4 is 2, which is equals a plus 1, taking 1 another side. So a equals to 2 minus 1, which is 1. The same way here also, 1 plus b equals 0 plus 2 is 2. So the b value is 2 minus 1. So b value is 1. A value is 1 as well as b value is 1. Question. Prove that a parallelogram circumscribing a circle is a rhombus. So first draw one parallelogram. Name this parallelogram ABCD. Parallelogram circumscribing a circle. It means circle is inside the parallelogram. This is circle which is inside the parallelogram. Now this circle is touching the parallelogram at some points, right? Those points I am taking as some PQRS. PQRS. Now he is asking that then we need to show this parallelogram is nothing but a rhombus. So first he gave that it is a parallelogram, right? What are the properties of parallelogram? Based on the sides, opposite sides are equal to each other. So based on this ABCD parallelogram, we can write AB equals CD. This side and this side both are equal to each other because these are opposite to each other. The same way here BC and here AD both are equal. So that is BC equals AD. This is equation number 1. This is equation number 2. I'll keep it aside for some time. Now you need to do a small rough work whenever you see this kind of question. That is, prove that a parallelogram circumscribing is a rhombus, or else they will give one quadrilateral ABCD like this. A, B, C, D, and they'll ask you to show that AB plus CD equals AD plus BC. Actually, this question continuation is this question. So, in this question or else in this proving a parallelogram circumscribing a circle is a rhombus, in these two, you need to remember some logic compulsory that we will see now. Remember this equation here, AB plus CD equals to AD plus BC. If you remember these equations as well as the logic, then it will be very easy to solve this without doing any mistake. Here you can remember it, otherwise you can do a rough part. That is AB, this side, plus opposite side CD. That should be equals to this side plus this side. That is AD plus BC. This is a rough part only, not main part. Okay, now here left side we have AB and CD, right? So write those AB and CD. AB means what from the given question? Check once. This AB, right, completely from this diagram. AB is nothing but AP and BP, right? So AB, I am writing it as AP plus BP. The same way, CD is total this base, right? So CD is nothing but CR plus DR. So CD is CR plus DR. So here in this logic, AB plus CD are left side. So it means this AP, this BP, CR, DR, everything should be towards the left side only. So now write our main answer. AP equals BP equals CR equals DR equals. Now observe the question clearly. This is a point which is outside the circle, and this AP will become a tangent and AS will become a tangent. From the point outside of a circle, always the lengths of the tangents are equal to each other. So AP and AS both are equal. The same way here, B is a point which is outside the circle, and BP is a tangent and BQ is another tangent. So BP equals to EBQ. The same way, C is one point and outside, that is CR equals to CQ. So CR is equals to CQ. Next, DR, right? So D is a point outside the circle. So DR is a tangent, DS is a tangent. Both are equal to each other. So DS. Now these four equations you need to do addition. Then what will become? AP plus BP plus CR plus DR equals, right side also addition, AS plus BQ plus CQ plus DS. Here if we observe AP plus BP, the figure if we observe AP is this part and BP is this part, right? So AP plus BP is total length AB, plus the same way CR plus DR, if you observe the base, CR is this one and DR is this one. So CR plus DR is nothing but CD, which is equals to AS plus DS. AS is this part and DS is this part. So AS plus DS is AD plus BQ plus CQ. BQ is this one and CQ is this one. So BQ plus CQ is the total as BC. Now try to compare with this, the first one what we wrote. AB is exactly equals to CD and BC is exactly equals to AD, because these two are parallelograms, correct? So now what I will do, AB I'll keep as it is, plus the CD I am replacing with AB now, equals AD I am keeping as it is, plus BC I am replacing with AD because the parallelogram property, right? So AB plus AB is 2AB equals AD plus AD is 2AD. Here 2 will get cancelled, then we remains with AB equals AD. This is the equation number 3. Now from the conclusion, from the equation number 1, 2, 3, we can say that the parallelogram circumscribing a circle is a rhombus. Then before this we need to write AB equals BC equals CD equals DA. All sides are equal to each other, then it's a rhombus. Next question, prove that sec A of 1 minus sin A into sec A plus tan A equals 1. Here write the first one as it is sec A. Open bracket 1 minus sin A as it is into sec A plus tan A. Now observe this clearly. Here we are given with sec A plus tan A. We have one identity related to sec and tan, right? That is sec square A minus tan square A equals 1. So here sec A plus tan A is there. We know one formula, that is A plus B into A minus B equals A square minus B square. Here sec theta plus tan theta is there, means if we have sec theta minus tan theta, then we would have been solved for one identity, right? So that's why based on that logic, sec A plus tan A I am not touching, I'll keep it as it is. First I will solve these two only. Now sec A into 1, which is sec A, minus sec A into sin A, sec A sin A. This total part as it is, again sec A plus tan A, sec A plus tan A. Here sec A as it is minus sec A, I am writing it as 1 by cos A, this sin A as it is, times sec A plus tan A. Close it. Now here sec A as it is minus 1 into sin A is sin A, right? So sin A by cos A, which is tan A, times sec A plus tan A as it is. Here sec a minus tan a, which is in the form of a minus b, sec a plus tan a, which is in the form of a plus b. A minus b into a plus b is a square minus b square. So sec a minus tan a into sec a plus tan a is sec square a minus tan square a, which is nothing but 1. So the value of the given question is 1, hence proved. Find the dimensions of a rectangular park whose perimeter is 60 meters and it is not R, it is area, and whose area is 200 meters square. I repeat, dimensions of a rectangular park is asking and where perimeter is given. So we know perimeter of a rectangle formula is 2 into L plus B. That perimeter is given as 60. So if you do simplification, 2 times 1, 2 times 30. So L plus B equals 30. Next, area is given as 200, right? So area is nothing but length into breadth. So L into B is given as 200. Now here length and breadth is given as 30, right? So from that what I will do is length is unknown, so I am taking it as x. Then what will be the breadth? Sum of length and breadth is 30. Length I took as x, then breadth will be 30 minus x. Here I have length into breadth, that is area, right? Area is 200, right? Length is x and breadth is 30 minus x. So x into 30 minus x, that is length into breadth equals to area 200. Multiplying x into 30, 30x minus x into x square equals to 200. Taking everything to the right side, minus x square will become plus x square, plus 30x will become minus 30x, plus 200 as it is, which is equals to 0. Now let us try to split the middle term into two terms, or else we can go with the formula also. Anything you can get the answer, no problem. X square minus 30x plus 200 equals to 0, right? So x square as it is. This minus 30x I am writing it as minus 20x and minus 10x plus 200 as it is equals to 0. In case if the coefficient of x square is 1, then direct answers we can write. This minus 20 will become plus 20, so x value is plus 20. This minus 10 will become plus 10, so the x value is plus 10. So the x values are 20 and 10. What is the meaning of x then again? Well, let us move to the previous one once. What we took x and y means. Here x length, right? So length is 20. 30 minus 20, 10. In case x if I take as 10, so 30 minus 10, 20. So 20 comma 10 or else 10 comma 20. Let us find out the mean of this question. Class intervals are given as 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. And frequencies are given as 1, 2, 1, 5, 6, 2, 3. First, let us try to do the mean by direct method. So, the first column will be class interval. And the second column is frequency. The third column is class marks, that is xi. And the fourth column is multiplication of the second column and third column, that is fixi. So, the class intervals are given as 0 comma 2, 2 comma 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. And the frequencies are given as 1, 2, 1, 5, 6, 2, 3. Now let us try to find out the class marks, that is nothing but xi. So class mark is nothing but average of the class intervals. Here the first interval is 0 comma 0 to 2, right? So add that and divide those. 0 plus 2 divided by 2 always. 0 plus 2 is 2 by 2. 2 by 2 is 1. So the xi is 1. For the second class interval now 2 to 4, right? So add 2 plus 4 divided by 2 equals 6 by 2, which is 3. Right here 3. Now no need to find out for everything. Just try to find out some logic in between 1 and 2. 1 and 2 are difference are subtracted by 2, right? Sorry, separated by 2, right? Now keep on adding 2 next onwards. 1 plus 2 3 plus 2 5 plus 2 7 plus 2 9 plus 2 11 plus 2 13. Now the last column is fixi, multiplying. 1, these two numbers we need to multiply. 1 1s are 1. These two again, 2 3s are 6. 1 5s are 5. 5 7s are 35. 6 9s are 54. 2 11 22. 13 3s are 39. Now this last column you need to do addition and write it as sigma or summation fi equals. The same way second column also you need to add and write sigma fi equals or summation fi equals 1 plus 6 7 plus 5 12 plus 5 17 21 20 23 23 plus 9 32 2 here and 3 carry 3 plus 3 6 6 plus 5 11 12 13 16 so sigma fixi is 162 the same way now here frequencies if you check 1 plus 2 3 3 plus 1 4 4 9 15 16 17 20 now we are doing with the direct method right so let us write the direct method formula first mean is x bar so the direct method formula is sigma fixi or summation fixi divided by sigma fi or summation fi. Sigma fixi we got it as 162 divided by sigma fi that is 20. So here 2 times 10 2 times 81. 81 divided by 10 is 8.1. So the mean of the given is 8.1. All the black face cards are removed from a pack of 52 cards. First of all, total cards are 52, right? These 52 cards they are divided into two sets. Those are 26 red color and 26 black color. In this 26 black color, we will be having clubs and spades. Whereas in the 26 red color, we will be having hearts and diamonds. So 26 are divided into two parts, right? So 13 hearts will be there, 13 diamonds will be there. The same way 26 cards are divided into black, right? So clubs will be 13 in number and spades will be 13 in number. Now the question is, all the black face cards are removed. What are the face cards first of all? J, Q, K are called as face cards. Now total face cards will be 6 sorry 12 12 face cards will be there in that 12 6 are red color face cards and 6 are black color sorry now here black face cards he removed completely so black face cards he removed completely means 6 cards he is removing total cards are 52 in number now he removed 6 black cards 52 minus 6 is 46 now the total number of cards are 46 okay now the first question is find the probability of getting a face card first we have 12 face cards right but from that 6 red face cards are there and 6 black card we removed right so only 6 are available now 6 divided by total 52 oh sorry 6 he removed right already so 46 so it is 6 by 46. Cancellation. 2 3s are 221 times. Next, red card. How many red cards will be there? In overall total 26 red cards are there and we did not remove anything from red. So 26 are as it is only. So 26 divided by total 46. Next coming to this black card. Total 26 black cards are there. But from that, all the black face cards we removed. Those are 6 we removed. So remaining are 20. Then 20 divided by 46. And the last one is king. King's total will be there 4. In hearts, 1 king. In diamond, 1 king. In club, 1 king. In spades, also 1 king. This heart is there. This diamond is there. And black face cards he removed, right? It means from this king also gone. From this also king gone. So only 2. 2 divided by total cards are 46.